Professor of Physics at Quinnipiac. That's it.
Michael Nabel from Quinnipiac University.
Hey, all right. Hey, welcome, Mike.
Good evening.
The professor.
My name is Michael, and I do various types of tricks. Many are based on mathematical principles. Until July, when I retired this year, I was a professor of mathematics and physics at Quinnipiac, and I used to do a lot of shows for the students and for the faculty. And every show that I do starts with a rope trick. I don't know why, but I guess the first rope trick I ever learned was called Professor's Nightmare. And it sort of stuck. I'm not going to do the routine, it's 11 minutes, and I don't want to do that. But what I'm going to show you is part of it, which is called cut and restored rope. And of course, the first thing you have to do is cut the rope, which I do like that. And so now you have two pieces of rope, and that's the cut, that's easy. Restoring is very difficult. You have to tie a knot that really works well. Now, I know two different knots, so I'm going to try the first one. This is a little tricky. If you don't tie it right, it doesn't really... Yeah, that looks pretty good. Yes, that's perfect. It's some of us call it a walking knot. I call it the eyeglass knot. Now, it doesn't look restored, so let's start over. And as I said before, what you want to do is, by the way, I'm going to tell you that ends are superfluous, so you can pull them right off and just you're not interested. All right. So what we're going to do is restore it with a standard knot. Now, the standard knot looks something like this. And if you do it right, it really looks like it's restored. Yes, it looks perfect. Hey, restored. No, maybe the knot should be down here. I don't want it restored. See, if I go like that, it looks restored, doesn't it? Not impressed. Well, suppose we do this. Drop the knot, and now it's completely restored.
Yes. Oh my God.
One of the things I have a lot of fun with is we don't work with physically touching things, but we use our mind. I have here 4 large cards. They are all queens. Clubs, diamonds, hearts, spades. Okay? And we're going to do a little experiment without actually touching the cards. I'll show you how it works. One card. Take the other card. You can't see them, of course, but I can. They're both the same color. I'm not going to tell you what it was, but that's how you select the cards. Simple as that. Perhaps you could help me. I'd like you to just think about, stay right there, taking 2 of the cards, but make them the same color. Just pull them right out of there, in your mind. I don't see them. That's good. You have 2 cards the same color? Those are the ones you removed. I didn't tell you you did. What color are they?
Blue.
The red or black?
Oh, it have to be red or black.
Club spades are hard time. You want to
Black.
change your mind? They're black. You have removed the black cards. Are you sure? That
No,
looks
I'm not sure, but yeah, good.
Oh, let me see. Oh, yeah, there you go. So there are 2 red cards here. One of them is the Queen of Hearts, the other is the Queen of Diamonds. I'm going to turn my back. Turn one of them over. Just turn one of them over. Don't tell me which one. Either the diamond or the heart. If you do that, you turn the card over. Don't physically do it. All in your mind. All in your mind. Did you turn one over?
Okay.
Either the diamond or the heart. Either one. Don't tell me which one, but do. You got one? Now put the 2 black cards back. I'll take them for that.
Oh, yeah.
Now, if this worked out right, 1 card is turned over. Either the heart or the diamond. Which one did you turn over?
The diamond.
The diamond. So if I take these cards and spread them, what you're going to see is one card turned over. I believe it's the Queen of Diamonds. Now, I have to tell you, I knew you were going to pick the Queen of Diamonds because that's the only one that had a red back. In fact, I was so sure I didn't bother bringing any other queen. No, it's a little warm. These are fun things I used to do with my class. I have to tell you, in my travels, I came across a deck which is absolutely amazing. This deck actually could be a calculator. Now, it can only do addition, subtraction, multiplication, division, but it's perfect. It can do any problem that you could do with a calculator. It's fantastic. Not only that, it has the ability to read minds. And I'll show you what I mean. Would you help me just think of a number? Keep a small number. Just think, don't tell me what it is. You got a number? Would you, excuse me, also help me think of a small number? As a matter of fact, what I'm going to do is make life easy. Here's a calculator. Calculator. It's just addition, subtraction, multiplication, division. You don't even need it if you take small numbers. What happens is, each of you think of a number. Each of you think a number? Hold on. Got it. Are you sure? I got it, okay. What we have to do now is all four operations. Let's do multiplication first. We'll make it easy. Multiply by 2. Take your number, whatever you started with, and multiply it by 2. Did you get that? Now you have a new number, right? Now we're going to add. We're going to add different numbers. I usually use the month. 7th month. Add 7. We're going to add a smaller number. Only add 5. Now you have a new number. You have a number, right? So we've done multiplication and we've done addition. Are you up for division? Yeah. Okay. Divide by 2. That's the simplest thing to do. Just split your number right in half. Yeah, I know. It might be a large number. We have one operation left, subtraction. Remember the number you started with? Subtract it from the number you have now, and now you have your answer. And just remember that answer, because not only has the deck figured out what they are, it's going to find them. And here's how it works. You get all the cards out. I don't know if you can see, we have a big deck of cards. What I'm going to do is the following. I'll start with you. I'm going to start dropping cards one at a time, and you can tell me to stop anytime you want, and I will stop too.
Stop.
Stop? Do you want to start, yes or no?
Excuse me?
Did you want that last card? Or
All right.
no?
I'll leave it up to you.
So, this is a number that you have. I wasn't counting. I think there's 1, 2, 3, 4, 5, 6, 7. 7 cards. Okay. Now, what I'm going to do is count backwards, and you can stop me anytime you want. There's 7, 6, 5,
Stop.
5, 1, 2, 3, 4. This is the 5th card, and the one after will be the 6th. Believe it or not, these are the answers to the problem. What was your answer?
My answer?
Yeah.
3.5.
Well, it doesn't always. What was yours?
I have 2.5.
Yeah, that's what we had, 3.5 and 2.5.
No way. You had the half points.
The deck never fails.
Oh, my God.
He had the half, I was like, no way he could get the half points.
Yeah,
2.5.
that was very good.
2.5. That's a broken calculator.
Oh, yeah, right. Okay.
I'm like, you can't get it because it's a half number. He got it.
Wow.
It got me nervous. It's like, he's not gonna get the half number.
He did.
I know you need to.
What I'm going to do now is something that's, I have a lot of fun with. It's called calendar magic.
I'm glad you
Now, if you take a calendar, it's go to any month, let someone take any month. I just happen to hit February. But you can get what's called a matrix. I want it to be 4 rows, 4 columns. So I could have done 1, 2, 3, 4, and going down 1, 2, 3, 4, and I would have had these 16 numbers. But I could have gone over and started at 2, I would have had 4 different numbers and all. So usually, if I go 4 by 4, you can get at least 3, 4, 5 different ones. Okay. So I'm going to ask for a month. Tell me any month of the year. March. March. By the way, this is 26, I believe. Yeah, this is 26. March, January, February, March. And here are all the values. Where would you like to start? We want to get 16 numbers. So you did good with these, anywhere you want to start.
1.
So you want 1 through 4, and we'll go down here. Now, it's hard to see, so I'm going to take those numbers and put them up here where you can see them. Here they are. So we started with 1, 2, 3, 4. Oh, back in the thing, I should give it a roll start. Should always have a prediction. One, 2, 3, 4, and then we go to 8, 9, 10, 11. Then 15, 16, 17, 18. And finally, 22, 23, 24, 25. So we have 16 numbers which form what we call a 4 by 4 matrix. What I'm going to ask you to do, with a little help, is only choose 4 of these 16 numbers. But we're going to do it in a random fashion. Now explain what I mean. I have 3 different colors, and we'll let white, which I just drew a circle, 4 different colors. And we're going to arrange it. For example, one of the first columns is going to become the red column. What column would you like to be red? 1, 2, 3, or 4?
3.
So column 3 is the red column. What column would you like to be blue? First, second, or fourth? 4. 4 is blue. What color would you like for black?
Let's go with the 23.
You want the 2 or the 1? Can you
Oh, you could
Column
only
one
the
or
top
column
row, not down?
Yeah, column 1 or column 2?
Column 2, I'll take the 23 if I
No, but
could.
this one's the column.
All right,
That's 2.
there you go.
And that means column 1.
Mhm.
I'll just draw a circle, that's white. Now, let me explain. There are actually 4 different colors involved. There are 4 ways you could have chosen the first, 3 ways you could have chosen the second, 2 ways for the third, and then 1 way. If you multiply them, that's 24 different arrangements. Now I'm going to do the same thing with the rows. If you give me which row do you want to be red? Any row. Three?
Yeah.
Row 3. 1, 2, 3. That's the red. Which one should I move blue? What row is blue?
One.
1. Which one are you adding to the left? The second or the fourth? Which one is black? Second column, second row or fourth? Which means the second is the white. Again, there are 24 ways that could have been done. Therefore, the number of different 4 out of 16 totals is 24 times 24. There are 576 possible different sums. And we're going to get one of them by seeing how these match. So here's the blue row and the blue column. That's the number 4. Do you want to see that? Here's the white row and the white column. That's the number 8. Here's the red row and the red column. That's the number 17. And then we have the black row and the black column is 23. If you had given me a different arrangement, we would have had 4 different numbers. Let's see what we get. That's going to be 4 plus 8, that's 12, plus 17 looks like 29, 29, and 23, 52. Now let's just check. This is not a magic square. A magic square, every row and every column would be the same. The first column, let's see, that's 22, 30, 45. This has a sum of 46, right? 46, that first column, if you add all the numbers. 1 plus 8 plus 15 plus 22. I think that's right. 22 and 8 is 30, 45, 46. What about the last column? That's 15, 25 and 15 is 40, 58. So you can see, this is not a magic square. But we do see that the sum is 52. Now, even before we started, I put out a prediction. And my prediction says, the numbers you chose have been arranged below in the magic square. But before I did that, I said, although you had a free choice of the square, 4 by 4, I predict that the total will be 52. Not only that, I predict that the first column will have a total of 46, and the last column 58.
Wow.
But since you have a total of 52, I'll show you what I did, and I'll rearrange it here. I'm going to use exactly all the numbers here. I'm not going to change any of the numbers, just their positions, and produce a magic square so that every row, column, diagonal all sums to 52. Let me erase this, and keep the 52.
We all think we're good at math.
No, somewhat.
You'll notice that we still have the numbers that we had originally, But now, 25, 40, 48, 52. 19, 29, 23, 52. 33, 34, 18, 52. What about here? 25, 30, and 22 is 52. You can check it, every number. Not only that, the four corners. 5, 22, 52, 52. The two in the top and the two in the bottom. 22, 24, 22, 23, 52. 8, 15, 11, 18, 52. Diagonal, 52. Diagonal, 52. Four numbers here, 52, 52, 52, 52. No matter how you do it, you end up with 52. So I hope you enjoyed it. My son's birthday party, I got a great
Wow.
I saw you in
Mathematicians.
He's taking me out to
I
supper,
know. We need it.
as long as I
It's on
can.
the third to take it up the middle part.
Articles are boring today. You gotta have a little.
Wow.
Thank you, Michael.
Wow. Random. Just random.